Hi there. Today we're going to do electrolysis, continue with the electrochemistry. I just want to do this part B here. If you see electrolysis, okay, red color, electrolysis, and we do part B, okay? Now let's see what the syllabus actually asks us to do. The thing is to predict, right? To say what is it. First, the identity of the substance liberated. Okay, so to predict if there's a competition or no competition. Because you see in molten here, there's no competition, but it's aqueous here, they have competition for few cations or few anions or water. You can see after this water is very important because aqueous is water. Okay, so water plays an important part after you can see a bit different from your form 5. Okay, during electrolysis from number 1, the state of the electrolyte. Okay, the first thing of the state. So important to know what is given out because of the state. 2, the position of the redox series or the electric potential. That means that you got to use now is to use enoch values to determine what is going to be liberated. Okay. Thirdly, of number 2, here's one here. Number 3 is a concentration. Right. So 3 things today we will look at it and see how we would talk about electrolysis. Now, remember electrolysis, in your form 5 electrolysis, there are 3 rules of electrolysis. Maybe we got to talk about what is electrolysis, okay? Now remember here, there's a difference in definition for electrolysis. Well, in cells electrolysis. In cells, we have done cells already. A cell is here is a definition. Electric cell generates electromotive force, EMF, by conversion of chemical energy to electric energy, which means that the chemical energy here, that means there's a redox reaction happening, okay, where there's a loss transfer of electrons. So this transfer from the negative pole to the positive pole creates the electromotive force. Okay, so chemical energy is converted to electric energy. Now, electrolysis is a process with ions. Ions where? Ions in the electrolyte. Okay, now this is all form 5, electrolyte. Change into elements. That means from the ions, positive and negative, to charge 0. Okay, to charge 0. Elements is charge 0. When electricity is passed through it. This is very important. Okay, that means there must be a source of energy. Now, now look here. Now this is electrolysis. Okay, so this is a source battery, the source of energy. Electrons are flowing here, negative, and here's negative, here's positive. Okay, so this is electrolysis. This here is electrolysis. Okay, now I just want to show you a difference here. Now this is a cell. Right, remember the copper immersed copper electrode immersed in copper sulfate, right? Cu-Cu2 plus, and here's your zinc Zn2 plus. So this is a cell. So the whole thing can be seen. It can be like this, right? I'll put a bit smaller here. Smaller can see better. Okay, so smaller still. Okay, right? Now this is a cell. Remember? So I can hook up the cell to electrolysis, so the cell here. So in these 2 things here, right, the common things we're going to use is the enoch values. These are enoch values here. These are standard electric potential. Remember, these values you must be used for here and for here. So now it's very important to use the data booklet. Okay. So, of course, how do you use a standard electric potential for cell? Of course, we look at the 2 half cell here, copper and zinc. So, positive from the enoch cell here, we determine what the poles, from here for the cell, we determine what the poles, the poles. Okay, so because it's negative, this is positive, so zinc will be negative, and this is positive. Okay. So secondly, we determine the flow of electrons. flow of current or electrons. So from negative it comes up, or not, because here we undergoing oxidation. So here's oxidation, and here coming to here is reduction. But instead of going to a voltmeter here, right, we pass it to, well, electrolysis, 2 electrodes here. Of course, it's a carbon electrode, okay? So the point is now, I'm gonna make it bigger a bit, all right? So in this case here, well, what is this energy? These electrons here are, this one here is few electrons here, okay? So this is the carbon electrode here, few electrons from where? From the zinc. And this part here, the copper sucks up. It's like a vacuum cleaner, sucks electrons. So one will be source, one will be removal, okay? So the point is, well, what actually happens here? This, of course, must be electrolyte. As you said, the electrolyte can be 2 states. Say states, depending on the states. Can be, of course, one is molten, and one is what? Aqueous. Why aqueous? Because ionic substances will dissolve in water. So if it's covalent substances, it will not dissolve in water. There will be no iron, so there will be no electrolysis. So electrolysis is only for ionic substances which are soluble in water. Okay. So now this is the thing here. So now, so this electrolysis part here, this part here. So how are we going to determine? Okay, determine what is liberated. Remember what the thing here says. Okay, predict the identity of the substance liberated, right? From states, molten and aqueous. Of course, molten is very simple. You've seen before. Now in form 5, remember form 5 here, right? If it's molten, like for example here, for your aluminum oxide, right? You got here is your alumina. Okay, let's put here. Oh, sorry here. Okay, here's alumina, Al2O3. So when it comes molten, you just give you only your Al3 plus and your O2 minus. So there's only this things which are given out, because why? Now this is a positive, this is a negative, right? So this one will go to your, this aluminium, you can see here, right? Aluminium will go to the negative and will take electrons out. So it's very simple, right? So there's only the product, there's no choice, right? Only aluminium and oxygen giving out. But for aqueous, there is going to be a choice, right? No, for aqueous. So how do we determine if there's a choice? If there are 2 or more ions or possible things to be liberated. So in form 5, there are 3 rules for electrolysis. One, of course, the position of ions in electrochemical series. Now, this whole thing, which you learn in your form 5, comes from the standard electric potential, okay? All this here. So in form 5, just learn by heart. But in your A levels, you need to pick up the correct enoch values, okay? And of course, the second one, of course, is the concentration effect, right? You know the concentration, concentrated brine or sodium chloride chlorine is given out instead of oxygen. Right? So same thing here, we're going to see. Third, of course, is the reactive electrodes, okay? Like copper as the anode will dissolve. Now, all these can be determined from the enoch values. Now, all these are fantastic things. So this one here, sorry. Down here, right? All these things here, make it bigger, right? You use all these things, all these fellows here will help you to determine, right, what is discharge. All this here, okay? All these values here. That's why the use of your standard electric potential is very important. The choice in picking the correct one is very important, okay? To determine, well, as I said, the choice to predict what is the type, as you see here, okay, to predict the identity of the substance liberated. So it's all from your enoch values, okay? Whether it is aqueous or whether it's concentration effect is from enoch values. Of course, if it's a molten, no problem lah. Okay, so we go back at that. Okay, and the first one, of course, here. Okay, the famous one, right? Electrolysis of dilute sulfuric acid. Okay, remember it's dilute. So let's see here. So I rub it off here first. This one here, rub it off. All these things here. I don't want to disturb me. Okay. So I combine the 2 together, right? So remember here, right? From the cell here, from the source of electrons here, right? This is a negative pole, right? It's a negative pole. It's a positive pole. Okay. Now, what is inside here? To understand what is liberated, to understand the identity of the substance liberated. Okay, they say here you need to know what the identity of a substance liberated. To understand what's the identity, what is given out. Okay, so what is liberated? In Form 5, you need to know, of course, what is this electrolyte. So here's your H2SO4 equals, this one will give you, of course, if you ionize, acid ionize give you H plus and SO4 2 minus. Now in Form 5, you learn that the water also will ionize it, okay? But now in your Form 6, OH minus, this is it's a very, very weak electrolyte. Weak electrolyte. Okay, so the concentration of these two is, if it's neutral, they call it neutral, okay? If it's neutral, means neutral water, the concentration of H plus is, of course, 1 × 10⁻⁷. That's why pH is 7. Okay? Same thing with OH minus. So it's neutral, this is very, very low. Okay? And all our electrode potentials are concentration of 1 mole per dm cube, you see? So that's where it's going to change. But of course, you need to tune your mind a bit, like that's all. So here, there are all these substances there, okay? This one here, this one is completely ionized, got H plus, SO4 2 minus, and you got water, main one. These two are very insignificant, so we won't consider this unless it's an acidic solution or an alkali solution. So that means you got 3 substances here to consider. All right, now here, okay? So remember the choice of enoch layers is very important. So remember I've got H2, put over here, H2SO4, going to 2H plus, completely ionized. Why we say it's a strong acid, isn't it? Right, completely ionized plus SO4, 2 minus, and of course water. Now I won't put the H plus and the OH minus there, even though in Form 5 you say that. Okay, so there's 1, 2, and 3. Water you must take into account, no? Because water also can undergo oxidation and reduction. Okay, now, okay. Right, now, for your anode, which is the positive pole, of course, the positive pole, they will attract all the negative ions here, right? So the negative ions that will attract, the negative ions it will attract is, of course, SO4 2 minus. Right, so I put here SO4 2 minus here. Well, let's say I put up top here. I put this thing here for choice. SO4 2 minus. Okay. Now remember, in Form 5 you use this one here, OH minus. Okay. Now in Form 6 you don't, so you don't put this one inside here. So what is the other one that can attract to your anode is water, and it's very important now to know water. Okay. So there are 2 choices to be considered to predict, to pick out which one is going to be liberated. Now let's go to the cathode first. But the cathode, of course, they got H plus, of course, it's a very strong acid. So we assume it's over 1, okay? So that's why you can use one here. This is 1 molar, okay? Mole per dm cube. All right, so H plus here. And also water, because now water, see now, water. Water here, see that water can act, in this case here, can act as a reducing agent and can act as an oxidizing agent, see now. So here, act as an oxidizing agent. Oxidizing agent. It accepts electrons. Here, it acts as a reducing agent. Water can do both. I'm going to show you first the enoch values, and now you must learn to use it properly, okay? Right? Keep my eyes on the clock, you know, so I won't have to pass the 1 hour, unless you'll be bored to death, man. Now, you see our water, okay? So the choice of water, the first, of course, is here. I'm going to use blue color, right? See, water here. Okay, see, water, it can go backwards, what? Okay, of course, it's minus that, minus 1.23. Now, water also can go forward. You can see here, water can go forward. Okay, see that, water here. Okay, let's go forward. As I said, it can act as, in this case, what? is an oxidizing agent. Oxidizing agent, right? Itself undergoes reduction. Here H2 and OH minus. Remember that there's enoch value here. So you must look at all these values here. Look at the equations here. You got ask you for equations as well. So water can go to your cathode and your anode. So in this case, if it's a plus electron here, it will go to your cathode, isn't it? Right? With a lot of electrons. Yes, right? And of course, if it is acting as a donating electrons, it will go to your anode. See, this is the value here. So which one to choose from? So from here you can see that. Okay? Where is going to go? So because here we say that it's going to the positive pole, right? That means this positive pole is sucking up electrons. That means it must be donating electrons. That means this one here. Okay? That means you will see here, it must be donating electrons. That means, here. So to give out electrons, okay, water, it's here, here. Water gives out electrons, go forward. Right? So I got to quote this one here. Now remember to write the whole equation there because Cambridge always look at the enoch values of your data booklet, not your reverse one. Okay, so I put down here O2 plus 4H plus 4E give you 2H2O plus 1, 2, 3. You can see I quote this down here. Right? Okay, so this one here, of course, water attracts to the positive pole. That means if I put the positive pole here, okay, it sucks up electrons. So two things will come to here, right? SO4, 2 minus, and what? H2O. Both of them can come here, and your S2O, 4, 2 minus can also give electrons here. So water can go give electrons. Now, to go backwards here, right? To go backwards, this becomes negative. Negative. The negative means not feasible. So now who is more negative? Of course, this is more negative. That means more negative here means it requires more energy, more voltage. To overcome it, it must have a positive. See? So this one requires less energy. So because it's negative 1, 2, 3, so it requires less effort to get up. So this is being chosen. That means what is actually happened here is, of course, so I write down here the cell reaction now. Okay, cell reaction or electrolysis. Okay, reaction. Okay, that's in your positive pole. So what is happening? Your sulfate is not given out, but your water is, so actually it's 2H2O becoming this 2 here. I cut and paste. Okay, right? Becoming O2 plus 4H plus 4 electrons. Now the enoch value here is what? Right? Is minus 1.23. That means I require energy to overcome this. Okay? So you get oxygen given out. Okay? So what is the identity of the substance liberated? Oxygen gas, which is true. Now here. Okay? Now, if this is a cathode, okay? Now this is a cathode. Cathode means negative 8. Okay? So a lot of electrons here. So what are the things I attracted towards here? In my sulfuric acid, of course, H plus. Now, water also can, I told you, water also can accept electrons. So I chose this one here because why? Say accept electrons in. So I got to choose from my enoch values here. Where is the water that can accept electrons? Here, see. See, water can accept electrons. So I quote this whole thing here. Give me H2 plus 2OH minus 0.83. So I quote this here. So now there are two. The choice here. The choice of either H plus is given out or water is given out. Because both can give electrons. So which is easier to give out? Look at the enoch values. Okay. Now this one here to go forward, remember, is positive 0. 0 means that it's just a comparison, that's all. For the water to go forward, it's harder than negative means that it's not feasible. It means I require energy. So which is easier? Of course, this one is 0. Comparatively, it's negative. So it's harder to go forward. So here, cell reaction here. Okay. What's actually happening there? Of course, it's a negative pole. Of course, it's 2H plus 2E to give you H2 gas. And the E electrode is 0.00 volts. So, right? So hydrogen gas given out. So is oxygen gas given out. Now to see the amount given out, you know in Form 5, when you undergo electrolysis of your acid, right, you get oxygen and hydrogen, and the volume is 2:1. Why? Because 4 electrons here. So to make it 4 here same, I put times 2. So it's 4H plus 4E to give me 2H2. E naught remains the same. Okay, what's here? So of course that means you add up the 2 together, all right? Add the 2 together. Okay, in this case, I can put down here. Well, I can put 2H2O, right? Go to O2 plus 2H plus 4E, and you put this on here. 4H plus 4E to give you 2H2. Okay, so the overall equation for electrolysis is of course what? Remember, here is your, right, you bring this over here. So it's 2H2O, right, plus, you bring it up here, plus your 2H plus, you cancel this one here, right? H plus here goes to O2 plus your 2H2. That means the volume is 1:2, you know, okay? So as the H plus is given out, right? As H plus is given out, as water is given out, okay? So these 2 things are given out. So what remains, of course, is the thing becomes more concentrated, okay? So here you can see how you use the electric potential to select, to predict what is given out, okay? Right? Now, of course, now here, they will ask you, well, what is the minimum potential? What is the minimum EMF I must have? It means what the cell, this cell here, right? What is the voltage that this cell must, the E cell here must have to cause it to happen? Of course, it means, see, now to find the E cell, we use, remember, for E cell, there are 2, let me show you here. There are 2 equations now. Now, this one here, this one we use, this is the one we use for our for cell. Remember now, E reduction, of course, is this one here. E reduction minus E oxidation, okay? It means EMF of the cell. But for electrolysis, we use the reverse, okay? So E cell is equals to E oxidation minus E reduction. That means this is the EMF you must have to overcome, to provide energy for electrolysis to happen. This is the minimum energy, the minimum voltage, the minimum EMF. Okay, so how do we calculate it? Here. Okay, here. Remember now, so E, I use blue, so you can see the difference. Okay, so E for cell goes to E, remember, instead of reduction, we have oxidation minus E reduction. Remember, you must use the original E naught values, is equals to. So what is, which is undergoing oxidation, of course, is your anode, anode here, right? Oxidation. So which is the one undergoing, sir? Of course, this one here. What's the E naught? Quote the original one plus 1.23. So it's bracket here plus 1.23. Okay, you always get a positive sign. Minus, okay, reduction, of course, we take for H plus here. Okay, which is 0. Okay, put down here 0. So it's 0.00. So the minimum energy must be positive 1.23 volts. That means your battery must have this one to cause, you must have the minimum of this voltage to cause electrolysis to occur in the dilute sulfuric acid. Okay, right. Now, next one here. All right, you can see this is of course for copper sulfate, for copper sulfate solution. Remember, so what is given out? What is the identity of the substance liberated here? Okay, now from where you know what, okay, copper and what, and your oxygen, okay. Now why? So here, of course, you see, well, in this solution here, remember it's aqueous solution here, what are the ions present here that will undergo electrolysis? So copper sulfate gives you what? It will completely dissociate copper 2 plus what? SO4 2 minus. Now I told you again, in form 5 use water now. Okay, don't use it anymore. Tak boleh. Cannot. Okay, because why? You consider this is neutral. That means this is what, if you use the the electric potential there, is 1 molar now. It's not 1 molar. It's not. Okay, it's acidic but not 1 molar here. So it's again this one here, and your water. So the 3 will play a part. Okay, so you don't consider OH minus, okay, and your H plus, which of course you consider OH minus in your form 5. You use OH minus, okay, remember? I'll show you what you learn form 5, okay? Now, so electrolysis of copper sulfate, remember in the anode, right? Remember copper sulfate, I put down here, copper sulfate gives you Cu2 plus SO4 2 minus. Now in your form 5, you put H2O, why not? You H plus and OH minus. Okay. Now don't use this anymore unless it's for a very acidic solution. Okay. No. So you have what? You have got this fella here, and this fella here. So 3 of these fellas here will be undergoing electrolysis. 3 of them. So we won't use the OH minus, even though I quote down here. See, we won't use OH minus. I'll show you why, okay? Now, so to go to the positive pole, I write here again, the positive pole here. Positive pole, it means it's a vacuum cleaner, it sucks up electrons. Okay? So something must be giving out electrons, okay? SO4 2 minus, water, and in form 5, you say what? You say OH minus. Remember that this is a famous equation, isn't it? 4OH minus give you O2 plus H2O plus 4E. Famous equation for form 5. But don't use it anymore. Because why? To use equation, this must be 1.00 mole per dm cube, which is not true. That's why I cannot use this. Okay? So you consider there are 2 to pick from. Okay? Right? So now here's it. Okay, now let's go to here first. Okay? So now to go backwards. Right, to go backwards here. To go forward is positive 2.01. To go forward is plus 1.2. Now to go backwards, of course, is minus here. This minus here. So which is easier? Of course, the less minus, the less negative. So what is actually happening here? The cell reaction here. Again, choose the right one. From where? From your data booklet. So it's actually 2H2O going to O2, oxygen is produced, plus 4H plus 4E. Now this, of course, is your E, okay? You would reverse it, is minus 1.23. Okay, now here, for your cathode, right, it's a cathode here. It's negative, it's filled with electrons from the battery, whatever. So what is attracted towards here? Of course, Cu2 plus. Okay, and we won't consider H plus. Why? Because it is if H plus here is 1.00 mole per dm cube, which is not true. So we consider water. So water again is considered to come here to remove electrons. Why? You can see it can happen, but it's not here. Right? I told you already, it's not, isn't it? So look for the enoch values for water as a reducing agent and water as an oxidizing agent. Both are given. So here, plus electrons. So now, which is easier? For copper 2 plus, to take electron to become copper, which is positive, because forward reaction, positive. It means positive means what? Feasible, isn't it? Okay. For water to go forward is negative. That means not very feasible. Comparatively, who will be picked up? Of course, copper. So here, what is the cell reaction? Copper 2 plus, which you learn from 5, plus 2 electrons to give you one direction, to you copper. So the enoch value here is how much? It will be positive, 0.34. That's not. So, which means as copper is given out, right? So what remains? Of course, water remains, right? Okay, right? As what this one, water is given out. Okay, what remains? Oxygen is given out here, and H plus remains. So H plus, right, plus your SO4 2 minus It means the whole thing becomes, the final link, this thing becomes acidic, isn't it? Right? So the blue color will disappear and get acid. Now, of course, you can put them two together. I'm going to just write down here, okay, for easy sake, like CO2 plus. Okay, right? So I times 2, I put red color. Prepare everything so it's easier for us, faster. So times 2, here's 4, and here's 2. I'll leave this alone. So it's 2 plus 4 electrons to give me copper, okay, which is plus 0.34. Okay, overall reaction will be water is given out, plus of 2 CO2 plus goes to oxygen gas given out, plus copper also given out or deposited, plus number 4 electrons we cancel off here, plus your 4H plus here. So the H plus combined with the SO4 2 minus remaining here will give you sulfuric acid. That's not. So the E, now the E thing here, all right, you just add up, you give you, you just add up here, all right? Here you show a negative value, no? I know, yeah? That means it cannot happen. You minus off here, minus off, okay, it'll be 9, right? Minus off here is 9. Okay, one here is 11, 8, 0 minus. So it's minus 0.89. That means that to cause this to happen, right? To cause this to happen, where's the thing? Sometimes the cursor is gone. To cause it to happen, right? It's not feasible, but it's feasible if I have an EMF, right? A cell that is more than this. This must be at least a minimum of plus 0.89 volts to overcome this resistance. Now, you can get this value here again from your E cell. This is very difficult. E cell, remember? Okay, so the EMF E cell will be E, remember oxidation, oxidation minus E reduction. Okay, so who is under oxidation? Of course, anode, isn't it? Anode, oxidation here, remember? Right, going backwards here. Okay, right, so it's this one here, right? So remember, you use positive, isn't it? Because you quote the original one. So it's positive 1.23 minus, right? Copper is positive 0.34. Again, you can see you get positive now 0.989. That means this is the EMF of your cell. You must have to overcome the resistance in electrolysis. Okay, so the choice, that means what is given out? Copper and oxygen. Okay, looks very complicated, isn't it? With all the enoch values here. But you must learn how to use it because they ask you later, like you see in Brian, okay? So this one, of course, you can use your Form 5 idea to predict. Okay, copper is given out, and of course, oxygen is given out, and remainder is sulfuric acid. Okay, now for aqueous dilute, remember that this Brian, now I got a picture here. Okay, remember, now this Form 5 picture, right? Aqueous, see, very dilute. They say very dilute. See, in Form 5, this guy also say very dilute. Right, which means there are no concentration effect. Right, it means here got NaCl give you what? Na plus Cl minus. That means this is below 1.00 mole per dm cube. See now, below. It means you cannot consider the concentration effect here. Okay, so in this case here, what is present here? Of course, this is given here, and the water. Again, water, you don't. See, they always say neutral. I show you a question, they say neutral, right? See, right? Starting from neutrals, So very important, see, they use water here, okay? So you must understand Form 6 is a bit different. You can't use OH minus and H plus anymore, okay? For aqueous, you must use water now, okay? So you can see here, I'm trying to finish off on timer, so I'm going a bit fast. If you cannot follow this fast, you repeat the video. Okay, so here water, okay, right? But of course in Form 5, you say, oh, you can, is it H plus and OH minus now, okay? So in Form 5, it says, well, this one is given out, or not, so the oxygen here. Remember that in Form 5 is given out is 4 OH minus. You remember to give you what? 2H2O. See, I can still remember plus O2 plus 4 electrons. So this is given out. Okay, so oxygen given out here. Right? And of course, these two here, because sodium is very high, so H plus is given out. So it's of course is 2H plus 2 electrons give you what? H2 gas. That's why you say H2 gas given out. Okay, so if these two are given out here, sorry, I say what I'm doing. Sorry. Hurry. Okay, if who is given out? If the H plus is any, right? If these two are given out, that means the concentration of any cell will increase now, right? And later it becomes concentrated, which is here. Okay, so that in Form 5, if it's concentrated, right? This for this case here, right? The hydrogen still is given out, but here Cl minus. For here, the Cl minus is given out. Remember, Cl minus is given out, right? You put on Cl minus here, 2 become what? Cl2 plus 2. Yeah. So in the Form 5, this is given out. That means the OH minus remaining. So at the end, who remains? They say after 4 hours, what remains? Remember, H2 gas given out, and your Cl2 given out. Okay, so these two are given out. H plus. So same, 1:1 mole plus 2 electrons. Yeah. So it's the same volume, is it not? So what remaining, of course, is your OH minus. OH minus and your NaOH. That means you get sodium hydroxide remaining, right? But that's Form 5. But let's get Form 6, okay? Form 6. They ask you now for dilute first, okay? Now if it's dilute, I told you already, right? Same thing here. You get what? Put down here, sodium chloride. Give you what? Na plus. It will completely dissociate. Remember dilute, so water, H2O. You don't consider the H plus and the OH minus together. Please remember that. So here, anode. Here's my, I put a cursor correctly. So here's my anode here, positive, sucking out electrons. Okay, so now remember, I put out all the possibilities. Now remember, now this Cl minus. Now this is only true if this is 1.00 mole per dm cube, but it's not. It's dilute. Okay, so you cannot consider this anymore if it's dilute. No. Okay, sulfate is sulfate. Why I put sulfate? Oh, I cut and paste wrongly. Okay, water, right? Water, H2O. Right now, H2O, because H2O also can give electrons. So OH minus, we don't consider this anymore, right? So this one, this not considered, it's not considered, right? So it's basically just water here, okay? So what goes to here is just water, H2O, and of course the Cl minus. But Cl minus is too weak, right now, okay? So you cannot use this anymore. So main thing is, of course, water. So what's the equation? They ask you for this one actually. So remember, it is going here and they give electrons. So electrons, these 4 electrons coming out here and they suck up here. So what's happening here? So the cell reaction is 2H2O, right? Going to O2 plus 4H plus 4E. And of course, the EMF here, right, for it, reverse is minus 1.23. Okay, so oxygen gas is given out for a dilute solution, which is true, isn't it? Oxygen gas. So here, for the cathode here, remember, is negative. Why? Electrons are pumping in here. So your Na plus is there. Na plus come here. All right. Your H plus cannot, because this one must be 1.0 mole per dm cube. Okay. So cannot, because neutral, they will tell you it's neutral. So this one cannot be considered. Okay. So then water, of course. So water can also take electrons, H2O. How do you know? Yeah, there's the equation. So now these two, which one is easier? Of course, the less negative is it. So actually here, water again is given out. Okay, so same thing here. So water 2H2O plus 2 electrons to give you what? H2 plus 2 OH minus. Okay, So here, remember the EMF is, okay, here is minus 0.83. Okay, so actually the whole thing here, you are going to put down here. Okay, remember here's 4 electrons, here's 2 electrons, yeah, so must times 2, isn't it? So it's 4 here. I'm going to put red color so it's easy for you to see. So here's 4, here's times 2, 4, here's times 2, here's 4. So I'm going to put down here 4H2O plus 4 electrons to give me 2H2 plus here's 4OH minus. Okay, okay, right? So the E cell here is minus 0.83. Okay, so the whole thing here, all right, here together, now H2, 4 electrons here, okay, something is missing. Oh, sorry, I put wrongly this one here, okay, here, hold on I just pause. Okay, so we just add up everything. Number here, 4 is 6, so it's 6 H2O, okay, will become O2 gas given out plus 2H2 gas given out. So it's 1:2 ratio plus what? Okay, plus here 2 low. Okay, plus of course 4H plus 4OH minus. Right? So don't care. Basically, you want to count this 4 here. So this one here, this 4 here is actually 4H2O. Okay, so you can put down 2H2O becomes here O2 plus 2H2. So 1:2. Balance it. 4 hydrogen, 2. Okay, so of course the solution because less and less water, so the NaCl concentration will what? Will increase. Okay, now this normally they will ask after you see there's one question on this. Okay, if oxygen gas is given out. So here is oxygen gas given out. Okay, so the choice of equations is very important. Okay, now if it's concentrated, now here is concentrated, right? It's concentrated, yeah. So they call electrolysis of brine. Brine means concentrated NaCl. Okay, now I put down here all the things here. Of course, again, I can't paste wrong this one here. All right, so I have to put my chlorine here. Remember, it's NaCl going to Na plus Cl minus, which means it's concentrated. This will be more than 1, at least 1.00. It means I will consider this equation here because this is 1.00 mole per dm cube, isn't it? Because standard, okay? So this is considered now. Of course, this one I don't want to consider. This one here, this one here. Oh, sorry, this one here I won't consider this because OH minus, right? You consider this when you're doing your Form 5, so this is not considered, right? So you pick the H2O that will give out electrons again. Now let me show you again. H2O that gives out electrons. Now H2O here is sucking electrons. Cannot. H2O water that gives out electrons is here. See, it's not here. See, gives you electrons. So I gotta use this equation. This equation. Okay, O2 plus 4H plus. You can see here, O2 plus 4H plus. So got these two equations to consider now. So which is going to be given out? Okay, right? Right. Now, so Cl, remember, this is going backwards now, okay? Right? Going backwards. Okay? Going backwards. Okay? Remember, this is going backwards is minus 1.36. This is minus 1.23. Still, water will be given out, you know, but when the concentration of this one increases, right, you shift backwards more, you know. That means this becomes what? What? Less positive, isn't it? Right? less positive. It means that it will come to a point where it's less than 1.23. No, become less than 1.23. It means we say 1.19 plus 1. It means that it becomes less positive, right? It's going backwards here, right? So it means that in this case here, if it's going backwards here, it becomes minus. So be minus 1.19. Okay. Okay. Right. So remember, if you go backwards, it'll be less positive. This will be less positive, huh? Less positive. So this is, so it will be even like, as I said, positive 1.19 compared with 1.23. Okay. So if less positive means that going backwards is less negative, isn't it? So Cl minus is being given up. So the choice will be Cl2, Cl. So of course, what is happening here is actually like this one. It means the cell reaction is 2 Cl minus going to Cl2 plus 2 electrons, okay? Which is negative 1.36. Yeah. So here, now, if it's the cathode, that means it will be reduction, okay? So remember, if this is a cathode here, negative, okay, electrons here. So your Na plus comes to here, and the water. Remember water only, okay, you don't consider this because it will say it's neutral. Okay, so which is easier to be discharged? Remember, it's going forward here, This is minus 2.71. This is minus 0.83. It won't go forward, but it's easier. So this being picked, So here be water, 2H2O plus 2E to give you what? H2 plus 2OH minus, okay, which is minus 0.83. Okay, so remember, so what is given out here? Chlorine gas given out here, and hydrogen gas given out here. That's why you see now the ratio is 1:1. Why 1:1? Because the 2 electrons can put down here, 2H2O plus 2E to give you what? H2 plus 2OH minus. Okay, you might just put down here, easier for me to write. Okay, so the overall is, you can cancel off the electrons here. So it'll be what? It'll be 2H2O, the overall reaction will be plus 2 Cl minus, right? To go to Cl2 plus H2 gas plus your OH minus. So this is given out. Hydrogen gas given out and chlorine gas given out. Okay, right? So the solution will be left behind OH minus and of course Na plus, which will give you what? Sodium hydroxide after 4 hours. Okay, right? Now, of course, you can also now write what's the EMF of this one after you can see the equation come out. So EMF, that means what's the EMF of the cell that's required to overcome this negative part here. Remember, use of E oxidation, reverse minus E reduction. Okay, so who is undergoing oxidation? Right? Your chlorine, isn't it? So it's signing a plus 1.36. So here's plus 1.36 minus, here's who is happening? It's happening. Yeah. Okay, here's a reduction. So it's minus 0.83. So a total of how much? 1.36, 0.83 is positive 2.19. You need this voltage to overcome it. Okay, right? Now let's look at the question of this brine thing. Okay, here, famous question. Okay, I got 50 minutes to try to finish off the rest. Chlorine is manufactured by electrolysis of brine. Okay, brine, you must understand what is brine. Even though it's aqueous here, it will be concentrated. Okay, brine means concentrated NaCl. At the cathode, hydrogen gas given out. Okay, and they say OH minus is produced. Now, see, it's a cathode. Okay, cathode means what? Reduction. Okay, reduction. So remember, this one is water, see? See now, which means they actually tell you You cannot use, remember cathode is negative now. You cannot use H plus. You cannot use 2H plus. You cannot, tak boleh. Cannot. Okay, they tell you already, must use water. Okay, so this is not considered. No. Right? But the product at the anode depends on the concentration of NaCl. The solution is low or high concentration. Either oxygen is produced, it means this is for dilute. This for CO2 is what? Concentrated. So they should tell you. Okay, so remember here, if you were to do this in exams, what you do? Of course, I'll show you how to do, okay? So put here, anode or cathode, okay? Put your cathode first, okay? Cathode means what? Negative, okay? It's a positive anode. So what you do is, of course, you see, okay, they tell me water. Here's water, H2O. Okay, at the cathode. That means this is negative. That means H2O. Well, it means cathode here, it will undergo reduction. Okay, so this one here, all right. Now so I got to write this whole thing here. This one is over here. So what's the enoch for this fellow here? I can see. Water plus okay, so I teach how to see, okay, so it's not here, right, because this is given electrons, so it's not here. See, they are quoting you this one here. Can you see it's not? Okay, 2 H2O plus 2 electrons give you H2 plus OH minus. See? Right, see, 2 H2O plus 2 electrons give you H2 and so the enoch value for this, if you were to quote from here later, they will ask you one, minus 0.83. So here's this minus original one, here is minus 0.83. Okay. So the anode, remember this is NaCl. I'm going to put this blue so they can distinguish. Okay. This is NaCl. Remember NaCl. I'll go this lower. Na plus. I think we used just now already actually, okay, plus your water. Remember, right? Remember it's neutral. You don't use H plus and OH minus, okay? No, don't do this. No more. I repeat 1,000 times if you have to get in a big head, okay? No. Because they say neutral, it means you must use water. So I got Na plus and water and Cl minus. So what go to the positive pole? Of course, a Cl minus and water. Okay, so write equations for the production of an anode for water. Of course, water must come with this now. It means anodes undergo what? Anodes undergo oxidation. You have to know this, anode always oxidation. Okay, positive. So it means water must be losing electrons. So what is the equation for water losing electrons? Okay, see what this one cannot. So water is what? I'll use red color. So water is what? Gaining electrons, cannot. So water losing electrons means water must be on this side. Okay, so where's water on the side? Water going to side. So water going to this side here will give you oxygen, it means it's going this way. So you must, okay, 2H2O, that means your answer will be, right, here will be what? 2H2O, that means this is the equation happening here. Remember, it is unoxygen, it's going to, and you go and see again. All right, 2H2O give you O2 plus 4H plus 4, O2 plus 4H plus O2 plus 4H plus plus how many? Check again. Even I forget, you think you can remember. Okay, 4E is not 4E. So it's plus 4E. Okay, right. Of course, it's good to know here what's the enoch value. Okay, I mean in this direction means backwards, okay, or backwards here, backwards here. It's a minus 1.23. Minus 1.23. Okay, right. So it says, well, if the production of the anode is chlorine gas, that means it's this one here. Okay, so what is the equation? It means remember, it's undergoing oxidation, means 2Cl minus, of course, will give you Cl2 plus 2 electron. Now you can check what? No problem. This is just Cl, right? Okay, here we are. All right. Cl, okay, becoming Cl2. This equation is it. So of course it's minus 1.36. Minus 1.36. I put down here first. So this one is E naught here is minus 1.36. Okay, right? Going backwards, okay. So this is the, now look at the marking scheme, right? Marking scheme, okay. 2H2O minus 4E, no, 2Cl minus 2, so 1 mark each. Now they ask you for the difficult questions. Okay, here. For electrolysis to occur, the voltage applied to the cell must be at least as large as the E cell, okay, as calculated from the standard potentials. From the data booklet, calculate the E cell for the production of anode. So I told you the E cell, okay, right? You use this. Right? So E cell equals to E oxidation minus E reduction. Okay. So now who is undergoing oxidation? Of course, it must be your anode, isn't it? Right? Okay. Now for oxygen gas is given out, it means this is the anode. This is the anode. Remember, this is the anode. Because the cathode is fixed. See, the cathode is fixed. You see, the cathode is fixed. The cathode is always hydrogen gas. Right now, the cathode is what? Will be your what? Here's cathode. This is your negative 8. Okay, so this is your positive 8 in electrolysis. So, right? So if oxygen is given out, that means you're using this equation, and this equation. Okay, so right. So now oxidation is this one here. So this one here. Remember the original one is what? Remember 2H2O. Okay, look at here. Original one where it undergoes oxidation is on down here. 2H2O. See, okay. So here, right, is original one plus 1.23. So I put it here plus 1.23. Yeah. See, plus 1.23. Okay. I know. And of course, reduction, of course, is for the hydrogen one. Remember this one, okay? Right? Remember water, right? As a reduction. There's only one equation next to your H plus here on top here. See now, right? Water, okay? Okay, it's minus 0.83. So it's minus 0.8. Okay? Okay? Right. So minus you get positive 2.06 volts. Right? It means if oxygen gas is given out, this is the minimum, this will be the minimum voltage your cell must have to cause electrolysis. Now see what's the answer here. Okay, so see they use this equation. See, plus okay. So it's E oxidation minus E what? Reduction. Easier to use. So it's 2.06 is positive value here. Okay. Now if chlorine gas is given out, as they say, right? Okay. So here for what's the E cell for production of anode of when Cl2 gas given out. So if Cl2 gas is given out, remember here of course is your chlorine. So what's your chlorine? The origin enoch values. Okay, let's get this. Okay, origin enoch values and keep my eye on the time. Okay, so remember this one's now. Even it's going backwards, but of course you call the original one positive 1.36. So it's positive 1.36. See here? Okay. Right, this is chlorine gas. Reduction, of course, same now for your water, isn't it? So it's you add them together, it's positive 2.19. See now, positive 2.19. So 1 mark each. Okay, right? See this one. If you put this on, they are very kind. They are very kind. See, if you show this, well, they give you mark lah. But why bother? You give the correct answer lah. Why depend on people's mercy? No need. You know the truth. What? Use the truth will set you free. Jesus said. Okay. Now here, by using one of the phrases more positive, less positive, or no change, use the equations you wrote in A. So here, here, right, to reduce the effect of increasing Cl minus. What is the E naught for the anode if production of O2, right? If you increase Cl minus, now remember, if O2, this is the equation, right? Or you can say it's reverse, if you want to say. Now, if you increase Cl minus, will it affect it? Of course, no, because there's no Cl minus here, isn't it? Right? No Cl minus. Put red color. No Cl minus, so it wouldn't affect. It means this value here will stay the same. Right? See? So here, no change. Because why? There's no Cl minus in the equation. Now if Cl2 gets given out, okay, this one here. Remember this reversible, right? If this increase, it will go forward more, or in fact, it will go backwards more, so look clear, right? If it increases one here, right? Now this for 1.00 mole per dm cube, right? If it increases to maybe 5 molar, it will go back more, isn't it? So it go back more, it means it becomes what? Less positive, less positive. That's not. Less, maybe 1.02, whatever, less positive. Okay? So remember here, it says less positive. Okay? So less positive, see the markings here? See, it becomes smaller or less positive. Now, they ask you now for the overall change. Okay? Now here, we end with this. All right? Hence, explain why the amount, this is the amount, the ratio, the amount of Cl2 to oxygen ratio will increase as any cell increase. That means that as any cell increase, this fellow here becomes less positive, right? That means less positive. That means you look at here, means less positive, right? That means it becomes smaller, not smaller. If this becomes smaller, this becomes smaller, not right? If it becomes smaller, means 1.00. Okay, that means this will just be what? 1.83. That means easier than this fellow here. Right? Easier than this fellow here. So that's why that means more chlorine gas given out. That's why it says here. Now, how you put it in words? The electric potential for Cl2 will decrease. It's true, then, because less positive, right? Less positive. Yeah. See? Less positive will decrease. Okay, you quote the original enoch values, okay, will decrease, right? Okay, and E for the potential for E for O2 remain the same because the Cl minus does not affect it. So therefore, the E cell of increases, the E cell for giving out Cl2 will decrease, hence become easier for the voltage to be attained. I'm marking same. The overall E cell, say overall, okay, will decrease. It means a smaller EMF. Okay, EMF, right? Will decrease. That means what? Easier or not? Right? Oxygen will stay the same, but it means chlorine gas will be easier to be given out. See now? Okay? So that's how you answer the question. Now I have come to the end of this family. Okay, now concentration effect. So well, tomorrow I'll try to do another one. Okay, which give you more examples. Okay, now please go through this and try to think over. You need to think over about this something. It's not easy, I took 4 hours to prepare this stupid thing. Okay. So all right. So I'll see you tomorrow. Hopefully I'm not lazy. Bye bye.